hit record, and looks like all the audio is working, or else we will find out the hard way when I try and upload this to YouTube, and there isn't any. um, but yeah, so thanks for joining, everyone. Welcome to the cadCAD community call number 19, I believe this is. So been going up for a little over a year now, which is pretty exciting, and I think there's been a lot of developments in the tool, and the community's been growing along with token engineering, alongside token engineering too. So exciting time to be within cadCAD and interested in cadCAD. For anyone who hasn't joined yet, the community call is usually just a space where we give community updates and have presentations from folks around the community that are working on their own projects or working for different projects and are using cadCAD for their modeling needs in their projects. So we've had people from the token engineering community doing governance research that have presented on reward systems models. We've had different integrations with machine learning and reinforcement learning agents in cadCAD models. Number of like digital twin presentations and stuff like that of different token engineering ecosystems. So lots of very cool stuff, and it's all available on the cadCAD YouTube channel, recordings of all 19 calls, or 18 plus this one coming up. So if you're curious to see what we have talked about in the past, definitely go check it out. Lot to learn. So and then also just connecting anyone interested in cadCAD and celebrating the work that people have been doing with cadCAD. So that's why we're here today. And we usually also just start with some hellos. So we can go around. I think there are a few new faces in here for me at least. So I think we can just do a quick round of hellos before getting into the presentation. The topic today will be the sigmoid bonding curves, or bonding curves simulations in general, that Quiet Catalyst has been working on through the cadCAD study group, and also some thoughts on version 2, or the second iteration of the study group coming up. So Quiet Catalyst will be presenting today, but yeah, so let's start with some hellos. If you'd like to just go around, I'll start, and we can do something like name where you're calling in from, a little bit about your background, and then maybe how you found cadCAD, or how you think you'll use it, or how you want to use it, or how you think you'll use it, something like that. So I can start. So I'm Heater, and I'm calling in from Berlin these days. Sometimes I'll also be calling in from the US, but at the moment in Berlin. And I have a academic background in economics and math, and have after a couple of years working in data analytics with an e-commerce company, kind of found token engineering and decided that was the path for me. So I got sucked into the token engineering field, and then found cadCAD just through an interest in modeling and simulating token economic systems. Have been kind of on a learning journey of what systems modeling is, how to apply math and use math to help model systems, and then cadCAD's obviously a really powerful tool for doing that. So that's what I think I want to use cadCAD for. Then I will pass it off to Enti. Would you like to give a quick intro?
Thanks. Hi, everyone. I'm calling from Santo Domingo, Dominican Republic. And so I'm really an audio engineer, but I've been in the space for a little more than a year. Currently just exploring, contributing a bit on the Token Engineering Commons, and recently contributing here in cadCAD as well. And just really excited to see what's happening. And just to say that, I guess my contributions are mostly on the community level, or some community operations, one could say. And yeah, I think that's pretty much it. I'll pass it over to Angela.
Yeah, thanks, Santi. Hello, my name is Angela. I've been around since 2018. Started first token engineering meetings, and now I'm running the Token Engineering Academy. I have been in the workshop when cadCAD was released and open sourced in 2019. And since then, of course, I'm user of cadCAD. Unfortunately, not too often, but then, of course, observing the functionalities, the upcoming cadCAD 1.0, to make it available for the students of TE Academy and to find the best ways to train and help people make use of it and contribute to it. And I'm located in Berlin, and I'm most excited about this session to see what's the outcome of the study groups you have been running, Peter. All right. I'll hand over the mic to James.
Greetings, friend. It's so good to hear from you again. I'm actually calling from London, but I'm originally from Sydney. I've now relocated here. My background's in engineering, which included some modeling of mechanical systems, and I did some of that in my thesis. And also I studied computer science with some AI subjects with agent-based modeling. So yeah, when I came across token engineering, I was like, this is a match made in heaven. And so I've been in Ethereum since 2017, and then discovered token engineering along the way. Saw cadCAD coming out, like same as Angela, and I'm sort of keenly awaiting products in the Web3 space to sort of understand and have a demand for this area. And so I perhaps dragged my feet a little with the study over in the past. I think I have helped contribute in terms of bringing over some cadCAD tutorials from one repo to another. So that's been my contribution to date, and doing some of the earlier tutorials. But that aside, I'm still very excited about this space, and I always check in every now and then. And I'm so glad to be in a time zone where I can join this course a little easier. So that's me. I'll pass on to Pat.
Hey, thanks, James. I am Patty. I'm located in Brazil, and I am also with Angela and with Peter in the T Academy. I have a background in international relations, very much about politics and history and some of economics, but nothing mathematical. So I am still very early student of coding and learning Python, but I am mostly here to see how we can collaborate and find ways of bringing cadCAD study group to the T Academy in this new way, and to see how is a community call of this community. So yes, this is a little bit about me, and I think I'll pass it back to you, Peter.
Cool. So I guess Quiet Catalyst is last to do the intro, but maybe we can just turn this into the presentation. Before I hand it off, I can just ask quickly if there's any questions about maybe the intro that I gave about the community calls, or the cadCAD community in general, or updates on anything cadCAD related that I might know the answer to before we jump into the presentation topic. Cool. All right, then I'll hand it off to you, Quiet Catalyst. Maybe you can start with an intro and then just jump on into the topic. But excited to hear.
Great, thanks, Peter. Quiet Catalyst, also known as Mike, dialing in from Santa Barbara, California. And my background is computer science with an emphasis in AI and systems modeling, or machine learning and systems modeling. But I've spent the last 15 or 20 years as a CTO in various companies, ranging from financial services to insurance, e-commerce, supply chain risk management. And so I discovered token engineering earlier this year and have been digging in to try and learn more about it. I think it is a nice intersection of a lot of things that are interesting to me, and I think that the potential behind value exchange in this Web3 world is very exciting. And so I've been trying to learn as much as I can, and as part of that, joined the cadCAD study group to learn more about cadCAD and also hopefully pick up some learnings about token engineering along the way. And so what I'll share with you today is the result of the cadCAD study group that ran for, I think, on the order of 8 weeks, and is just now sort of transitioning into a version 2 of that group, which we can talk about after we talk about this application. So let me see if I can share this. Can you see my screen? Okay. So I'll start by giving credit to this Medium post, which kind of got me started on this notion of sigmoidal token bonding curves. And prior to this, I'd read about some of the other bonding curve forms. And I was kind of captivated by the sigmoidal approach, given that sigmoid is a somewhat naturally occurring function that we see in systems. And so read through this paper by the group from Molecule, and got sort of a top-level understanding of the intention behind this approach to the bonding curve. And fundamentally, it's about setting up a system for supporting kind of long-running research projects and leveraging the nature of a sigmoidal function where it's sort of flat and has a low degree of slope early on, and then has an acceleration period with a steep slope in the middle, and then sort of levels out towards the end, leveraging those characteristics in a fundraising setting to manage how you want to incent participants in the network. And the way they've structured it is, as funds come into the system, they apply a tax on the funds that will be moved to support the research going on, and then the remaining funds go into the bonding pool, basically, to support the token itself. So I'll talk a little bit more about that as we look at the application. One nice thing about this is there was a reference to a code base, which I was able to leverage and use that to build the bonding curve part of what I will show you. And so I ended up refactoring that code so that I could have an application that would allow for substituting in different bonding curves over time. So it sort of translated into more of an object model where the bonding curve is an object that is part of a market. And so that provides flexibility for how we decide what the bonding curve should look like. And part of what drives this exploration for me is trying to get a better sense of how real-world behavior might relate to what's defined sort of ideally in this bonding curve mechanism. So I am now showing the app that I created as part of the cadCAD study group. And at the top of the app, I've included this image that is a system diagram of how this system is functioning. And so as I mentioned, as we were looking at the Medium post, funds come in, some portion of funds gets directed to this funding pool, which is used for operations. Essentially goes into, if you're doing research, one of the examples they give is on like drug discovery or something like that. So this would fund the drug discovery research. What remains after the tax, and how much that is determined by a parameter that decides either an amount of tax or the rate of tax against what's coming in. So what remains can be deposited into the reserve, and then tokens can be minted against that, returned to the purchaser in that case. And so if tax is non-zero in this system, then the buyer is always giving up money in their purchase. They're going to sell for less than what they buy for. And so they're just, by virtue of participating in this ecosystem, deciding to contribute through their tax to funding the research initiatives that are going on. But this reserve pool does allow for the value of the token to be established, and as with a traditional bonding curve, you can sell off your tokens or burn them and get back your currency that the bonding curve is mapped to. So this is what it looks like in terms of configuring the bonding curve. And the one we're looking at right now has a constant taxation model. So to break down these 4 graphs that describe sort of how the system is configured and how the tax and fund flows and how the stocks will fill on tax and fund. If we start with the price graph, if I'm buying tokens, this will be how the function of pricing goes according to the token supply. And this is set up so we can experiment with different token supplies. We can set different price points, and we can adjust the structure of the sigmoidal curve as we want to get a certain outcome. But the cell curve in this model, where we have constant taxation, means we're always taking the same amount out as a tax on the curve. Therefore, the cell curve always sits the same amount underneath the buy curve. So that tax ends up going into the fund that we'll talk about in this bottom right-hand corner. Those transactions can be also viewed in the context of how much collateral is required to buy, or how much would you get in selling that number of tokens. So you can see how over time the distance between the buy and sell curves creates this gap between buy and sell collateral. So this is what people are paying in, this is what people could be getting out as a result of selling, and the difference between these two actually ends up being the amount of funds collected through that tax, which is captured here on the red line in this plot. We can also see in this plot, the green line is telling us what is our fund rate, at what rate are we growing our funds, and that's trailing off over time against basically a larger denominator we could see just by looking at the collateral, for example. Similarly with the tax, if we're keeping a fixed tax amount, always 25, for all values of the token supply, then again, as the collateral grows, the denominator grows, then our rate of tax is going down. So this is kind of a sandbox for playing with potentially different settings on the bonding curves and basically what's going to govern how the system is managing funds. And then below, we can simulate what actually happens in this system if we run agents through the system. And so this is back to that question of, does the market behave in ways that we expect it to behave when we actually simulate activity on the market? And are there cases where things happen in maybe unexpected ways, or just new insights that we can derive based on interaction with the market? And so the simulation runs and shows what happens in the market as a result of participation with some set of agents. And the point where this application is at right now is pretty simple in that there's a single agent. It's almost like, you know, in software, when we build software, we do unit tests that are very simple tests on the software to make sure it's working. And this is kind of a unit test on the simulation. So we have a single agent. And if we look at the market graphs, we can see the single agent buys one token for each step of the simulation. So not very creative in terms of trading strategy, but very helpful in terms of evaluating, is the market responding in the way that we would expect the market to respond? And so for each step, we buy a token, and therefore the number of tokens in circulation goes up linearly by one each step. we can see how the buy and sell price breaks out, and that maps to what we saw above in our price graph. Our market funds balance can be compared to our fund graph that we had up here, the sort of idealized version, based on how we've set the curve parameters. And then our market collateral balance can be compared to our sell curve in the collateral graph up here. And so hopefully you can see that they're basically the same. So we're getting good results there. And then we can see how that relates to the agent in terms of the amount of capital that the agent has on hand, as well as the number of tokens that the agent has purchased over time. And you see the agent ends up with 1,000 tokens at the end of this, and their collateral is close to, but not quite zero at this point, their capital. So that's a walkthrough of the sort of whole layout of the application. Within the context of this concept of sigmoidal bonding curves, we can actually experiment with various scenarios, and these are things that were established by the molecule team. So, for example, we could say there's no taxation at all, in which case we're not raising any funds. We just have collateral, so it's a more maybe traditional bonding curve setup where we don't have a buy and sell curve. Or we could say we're going to decrease taxation over time. So early arrivers pay a little bit more in order to contribute to research in the system. And then as we go on, the tax goes down. And you can see how that affects how the tax rate looks, as well as how the funds come in. So now funds where they were previously coming in a more linear fashion, we have a more rapid ramp in the early days of supply, and then things kind of level off in the later stage. And this is set up so that we can simulate when those scenarios change. And so this simulation runs through cadCAD, and cadCAD is basically managing the interaction between the agent and the market. And then you can see we're getting similar curves here. So if we compare our funds curve with our fund graph up here, so that in red we've got this idealized, in green we've got actual from what happens through our simulation. Similarly with collateral, same kind of values on the sell curve as well as the collateral curve in our simulation, and how the agent over time is changing in terms of collateral and the number of tokens that they have. And so just to complete the picture, if you chose to increase taxation, then you could say, well, okay, now the late arrivers to the system are going to pay more in tax. That's going to change my funding by making more shallow slope as I'm getting started. But as we get traction, and so maybe the inflection point on the sigmoid is indicating a milestone or something like that. And if that milestone translates to more value, then we can justify increasing taxation there, so we get an increasing funding occurring later in the supply. And then this is quite clever, where if for some reason you wanted to basically tax around the inflection point, so saying the tax amount increases towards the middle of the supply curve, which coincides with sort of the inflection point around the sigmoid, you can set up that construct as well, and you can see how that changes the fund rate. I think it's not quite as shallow as it was before. You get this acceleration, so it's almost sigmoidal itself in the funding, where it accelerates and then starts to level off as we reach maximum supply there. We can simulate that. So for next steps, I would like to obviously move this beyond a single agent simulation. So I think the validation is somewhere in the 90% complete range, and would like to see how this responds as we bring in agents, perhaps with different strategies. So we might have populations of agents who are looking for a certain reward target, or some who are just interested in supporting the project and thinking about what kind of behavior classes would we like to represent. And then if we have a pool of agents that's interacting with the market over time, how might that change some of these nice clean curves that we're getting now if we've got buying and selling taking place from a wide group of agents? How does that change the performance of the system? So why don't I pause there? We're at half past, and if anybody has questions, we can talk about those.
Yeah, first, this is really cool, Mike.
Thank you.
It's amazing. I like it a lot. I think, I mean, we have used such applications also for discussing the parameter settings for the TEC, and we also had a bonding curve. We also had a tax, and in our case, it's entry and exit fee, but a very similar setup without the sigmoid shape. And yeah, it's just cool. What's the framework you're using again for building this application?
Yeah, good question. So the cadCAD part is cadCAD 0.428. And then the graphics are through Dash, which is a Python library for basically for data dashboards or data visualization.
And also the entry, so the setting the parameters.
So these sliders are done in Dash as well.
Okay, all right.
That's part of the interface. And yeah, so it provides, in my view, it provides a more interactive framework than you can achieve with Jupyter. A lot of this can be implemented in Jupyter in a fashion, but I kind of like the single page app approach as opposed to the individual cell approach that you have with Jupyter Notebooks. Yeah.
No, it's really cool. I have, could you, the font graph and the text graph are not 100% clear to me. Maybe I missed something. So you, on one hand, you have the absolute amount in terms of tokens, the red. So looking at the text graph.
The absolute amount is in currency.
Okay.
So this is in price. And so actually, if we go back, we take a look at constant taxation, and we start with the price curve and say the difference in price here, it must be about 25, between the buy and the sell curves. Then we look down here at the tax graph and see the amount is 25. That's basically the distance between these two curves. So that's
an absolute token amount. Okay.
Well, yeah, I guess I think of it in terms of if I were going to pay in dollars, for example, for whatever this token is, then this amount of my dollars would go into tax.
Yeah.
$25 goes to tax, right? And then whatever's left over goes into the reserve pool. So the tax goes to this dark green.
Yeah.
And then what's left over goes to the reserve.
Right. And the rate is the percentage.
Correct. Yeah, this is the tax rate. Yep. And then this, on the fund graph, we're basically showing how does that stock of funds fill related to the supply, and what is the fill rate as supply grows.
Yeah. Okay. Got it. Makes sense.
You know, one of the aspects, I can't remember if I made this point or not, but I think this is useful. When we do this mapping and define what the curve looks like, we're doing it
Mhm.
against the supply. When we do the simulation, we're simulating effectively over time.
Mhm.
The x-axis is labeled as a step, but each step is a time increment.
Mhm.
And so those two will not necessarily be the same. They are in this case because of the simple simulation that's set up.
Right.
But I think there's a lot of value in exploring how does the system behave over time as compared to how does it behave as a function of supply.
Mhm. I guess this is so. I just realized that this is actually super valuable for users of such applications because they tend to not differentiate between those two, and it's for the educational journey. It's really good that you took this super simple scenario where we have a one-to-one overlap, and then in more complex scenarios you'll see the difference.
Yeah.
Actually, who would you expect to be the users of this application?
Well, so I guess people who are planning token economies and or people who want a deeper understanding of token economies.
Mm-hmm.
At this stage, it is, I think I mentioned, it's kind of like a sandbox. So it's more of a tool for understanding than it is a tool for embedding in something, at least at present. If you were to expand this with other feedback loops that had to do with learning and so elements inside the system that were learning about the system and understanding it and taking action based on that, then maybe it could be something that gets embedded into token economies.
Yeah. I remember a spreadsheet that was designed or set up for a liquidity bootstrapping pool, and it was absolutely static. It was pretty much like the top section of your application where everything is mapped to supply. This was what the spreadsheet was capable to do, and no way to run a simulation and having more complex scenarios. But still, this spreadsheet, I guess over 2 years, basically was used by every single team that was thinking about liquidity bootstrapping. And here's, I mean, my message is sometimes the tools are incredibly simple, but once people get their hands on something to get a feeling, they are super happy, even if a token engineer might say, okay, this is not the full picture.
Yeah, which is always the challenge in modeling is
right.
We can't model the full picture, so we have to decide which parts of it do we want to model best.
Okay, cool.
I have a quick question. Through just analyzing some of the simulation graphs of the different scenario types, do you think you're able to make any generalized statements about like which type of or which scenarios might be useful in different, I guess, fund raising situations, or like for different fundraising use cases? So like you could raise funds for public goods, or you could raise funds for providing services, or you could raise funds for developing products. Yeah, just any like generalized comments about what different scenarios might be useful for?
Yeah, I think so. As we walked through some of these scenarios, if we use this as a baseline and say, well, this gives us a constant growth on our funds, then this says we always have funds coming in, right? We're building this as the supply grows, whereas if we contrast that with like this bell-shaped, then we still always have funds coming in, but we have less coming in early in the supply, and then we accelerate to have more and then level off towards the end of supply. And so it's those characteristics that I think we would then take and map to specific business cases, I guess, like what you're describing. So if a business is fine having a lower level of funding early on in the supply for whatever reason, but then as they reach certain points in their journey and want to accelerate that funding, then something like this might be applicable for them. So I think getting to the answer starts with thinking about how do we want to manage funding in the system, and then how does that map to how people want to manage the business that the system is funding.
Right. Yeah, so like comes back to business goals basically, which is one of the early steps in the token engineering process, I know.
Yeah, and as I mentioned earlier when we were looking at the molecule paper, so they started with this, what pushed them into this approach was this idea that when you're doing something like drug discovery, you have a long period of research, and there's work that goes on prior to even being able to think about commercializing a drug. And so they were attracted to this structure because it allows for this sort of long lead time where people aren't having to maybe overcommit, but then as you make progress, you can accelerate funding in order to get things to market.
Mm-hmm. Cool, really interesting. Yeah, and I guess I'm maybe not a question, but I think it'd be super interesting I'm excited to see the simulation results for multi-agents. I think, yeah, that's just like definitely the next step of complexity to add in for the bonding curve, and it would for sure, you'd definitely reach different outcomes if you have competing agents or people who are profit seeking or whatever it might be. That'd be
Yeah,
really cool.
I agree. I think that would be very interesting. And in the context of simulation, we can experiment with, let's say we define 3 different archetypes in terms of behavior. We can experiment with how much we want to weight each archetype in the pool. So, maybe it starts out as 1/3, 1/3, 1/3, or maybe you do, I don't know, 20% and 40%, 40% in another run, and compare those, which actually reminds me of another way to extend this is to be able to compare across scenarios. So the way it's set up right now, we can only see one scenario at a time. I can imagine how it might be useful to compare some of these different approaches and different outcomes just across scenarios with everything else, the parameters essentially set the same.
Yeah, very cool. And just going back up to the stock and flow chart, actually. So from a cadCAD perspective, would you be able to like point at this and say, these are the state update functions, these are the policy functions, and one time step is a flow from this point to that point in this chart?
Yeah, let me try and wave my hands at it. And I'll preface it by saying the cadCAD simulation is really simple at this point in that, as you may know, you can chain the partial state update blocks in cadCAD, and this is running in one block at the moment. And I've kind of gone back and forth. I've tried it with multiple blocks and a single block, and I'm running a single block right now just because it's simpler. But you could, as it gets more complex, I can imagine wanting to do multiple update blocks. So with that as a reference point, all this happens in a single state update, but within that state update, we are first starting with the agent, and the agent chooses an action. And in this case, the agent's action is to buy as long as they have capital. And when they run out of capital, then they will sell. And if it loops back around to them and they have enough capital to buy, they will switch back to buying. So actually, if you extend this out, you can see the agent oscillating between buying and selling as they run out of capital and sort of bounce around between not having enough to buy and then selling off tokens until they do and then buying again. So it starts with the agent action, and then the agent action goes into the market, which will manage between the tax and tax rate and sort of separating the funds into the funding pool and the reserve pool and returning tokens as a result. And then the last step in the update is to update the user with how many tokens they have and how much capital they have remaining, which is basically what you see in this plot down here. And so did I touch on all the cadCAD elements you had asked about, or did I leave? Yeah, okay. Yeah, I mean, yeah, you can call it that, and I'm calling it that in the user interface. Yeah, but it in some ways it's also just a loop over interacting with the market and creating transactions. But the underlying structure is such that within, so if we were to draw the software architecture, I'd mentioned I had refactored the code that the molecule team had put together to cover this part, defining the curve. And so within that structure, there are objects for the scenarios. There is an object for the market, and the market has a bonding curve. And what that structure enables is the ability to add multiple scenarios if we want to, and all of that is independent of cadCAD. We could change the bonding curve if we want to. So that lets us do potentially more types of experimentation in this sandbox. And then similarly on the agent/user side, that's defined as a class, so we can instantiate multiple objects of that class as we think about moving out into having multiple agents, and then they can have different policies that will drive their actions. That also is defined independently of cadCAD, and so cadCAD kind of sits on top of all that and orchestrates the flow of the simulation.
Awesome. Really interesting. I want to make sure we also have some time to get to the study group topic too. I don't know how much you think that'll take, but if you think we have time, maybe we do like one more question if there is one before jumping over. Yeah, does anybody
I was just curious. Sorry, I was a bit late, so I missed the beginning of the presentation. But I'm curious if this is on a repo or if there's anywhere that this can be played with. I really like the UX and I just wanted to run through some of the different scenarios since I may have missed that in the presentation. I don't want to drag everyone through that again, but I was curious if this was open or available to play with. And great work. It looks really cool.
Oh, thank you. It will be available. My intention is to make it available. I have not checked it in yet, but I think it's close to being ready to check in. So I've got a little bit more validation to do. I have one item I know I need to fix in it, and then just make sure the code is at a place where I'm ready to check it in, and I can do that. And I'm happy to share once it gets checked in and is available.
Cool. And it'll also be on the recording.
Yeah, fair enough.
Nice.
Sweet.
And maybe that's a good note for the study group. I don't know if maybe we have everyone work on the cadCAD repo from step one, just so that the code's always available. But yeah, just a thought. But yeah, any other final questions? Maybe for another minute or two on this topic before we move on. All right.
Okay.
Cool.
Let me
Yeah.
Switch tabs and switch gears. So as some of you may know, Peter was leading the cadCAD study group in the iteration that's effectively wound up at this point. And we're looking at how we can transition the study group as he has less time available, but we would like to keep it going in some form or fashion. And so I've been collaborating with ZC Star, who's another participant in the study group, to think about what might we do for a version 2 of cadCAD study group. I think the time frame of kind of an 8-week block feels appropriate. That's about what we did on this previous one. And so we've been collecting notes around this concept of how do we structure it in the context of complex modeling, systems modeling, with an emphasis on token applications. So my interest is in sort of applied modeling towards token engineering. But at the same time, we recognize that people coming into the study group have some needs for setting foundational concepts around systems and how do we define systems, how do we represent them, what are the different approaches using, for example, diagrams to represent systems, and how should we think about those things. And practically speaking, I found that going through the exercise of just identifying system components and how they interact with each other has a tremendous amount of value. It's not unusual for people to think, well, I need a simulation to do something. And then if they go through the process of identifying the different pieces and how they connect, that may get them far enough along that they don't really need a simulation. They don't have to go through the extra effort of actually implementing something to simulate the system. Simply going through the exercise of identifying and getting a deeper understanding of the system has value. And so we've kind of sketched out this idea of starting with systems themselves and using closed and open loop systems to drive that conversation, and adopting a sprint-based approach where we could execute in 2-week sprints to cover sort of an intro to systems. What are they? How do we define them? How do we think about them? And as part of that, add resources to the cadCAD wiki that is coming online so that we can be building a knowledge base from this. And a sort of general arc along the sprints is thinking that they would be 2-week sprints. And at the end of 2 weeks, it would be great if we can have an expert join the study group call to give feedback on the result of the sprint. And so in the first sprint, it would be around defining systems and diagramming them. In the second sprint, we would move through system diagrams into specification for a model. Also, I think the exercise of defining token models around systems. So as we apply this to token engineering, I just in my limited experience, I found this to be a very useful exercise to think about how can you take a system and tokenize it, basically. And I know, Peter, you'd done one with a plant almost a year ago now, which I think sounds like an interesting and slightly arcane approach to doing that. And then for the third, the third sprint, doing implementation of the model, and the fourth sprint would be doing validation of the model. If we take that in the context of what I shared today, so we'd be moving in the first or second sprint through this type of thing into the third sprint of implementation, and then finally validation, which, as I say, in this particular one is probably about 90% of the way there, but not quite complete. So let me pause there since I think we're coming close to 5 minutes left, and see if people have questions or comments on that.
I have a lot of questions, but in general, I think sounds super cool. I wonder, obviously you are moving from a pretty I mean, Peter, I remember our conversations on study group, self-defined learning goals, and so on. So you now moving rather towards a pretty well-structured but predefined structure, right?
Yeah, I think that's an area for discussion. And let me see if I can stop sharing that.
I guess my question is what brought you to this conclusion? Because I guess you have a good reason.
So the observation from the previous study group was that people would come on and have ideas for projects that they wanted to do. And some people had the foundation for executing those projects and some people did not. And so I think part of what is informing our thinking is around making sure that the fundamentals are there and that the material can be accessible to everyone somewhat independently of their level in terms of whether they can do development or whether they have experience with systems modeling.
Yeah. And I mean, I like the sprint structure a lot because it feels like even if you might have missed sprint number 1, you might still be able to catch up and join sprint number 2. I don't know how this looks like in sprint number 4 or 6.
Yeah, our thinking is if we choose systems that are simple enough, and I've switched to a Notion view of what I was just showing you because I think it's got a little more visibility into some of these things. If we pick a simple enough system, then our expectation is that it will be simple enough, even on the coding side, that people can hang with it. So if we took a thermostat, for example, that would be a simple system to define and model and enable people to work all the way through that process. And if there are others in the study group who want to work on something more advanced, I think we can be open to that. But yeah, I think intuitively we're leaning towards more structure that can keep more people engaged with it.
And then after you completed sprint 6, start again with sprint 1, or I mean, that's probably a little bit further down the road, so 6 times 2 weeks. This is already 12 weeks, but still, do you see then it could start from the beginning, or?
That's how I've been thinking about it, but I think we're still in an experimental phase in terms of what the right structure and cadence and frequency is, and then also in consideration of what's happening with the Token Engineering Academy. I think that there's going to be a lot of overlap in people who might be interested in this will potentially also register for the Token Engineering Academy.
And vice versa.
Yeah.
So since, I mean, sprint 1 to 3, I guess, is pretty tool agnostic, right? And then you dig into cadCAD once you start verifying and run simulations.
Yeah, and I think that it'll be interesting to see how that unfolds. I think there's value in looking at the different tools available and thinking about which tool should I choose for which situation. And there's some stuff that could be done in just pure Python, doesn't need the framework. But other things should have the framework, especially in order to get into more advanced simulations.
And actually, I would recommend to, let's say, play out this strength that this study group is about, having the chance to try out cadCAD, starting from a very simple, or let's say easy to access curriculum up to most complex simulations, whatever you might want to try out. I think the general structure is not too far away from the from the token engineering process at TE Fundamentals, but still people might be just keen. It's like you have to go over it again and again and again, so I don't see a problem here. In the TE Fundamentals course we are using, I think, just plain Python, and then the strength of this study group, of course, would be now try out cadCAD and see what are the benefits or the capability, the power of cadCAD.
Yeah. So we got feedback from one of our study group participants yesterday, and he commented that one, he liked the flow of this, and two, he didn't feel like he was ready to do programming, and so wasn't sure how he should or could participate in the flow. And I'm hoping that the way we've got this structured, where we are doing things like adding resources to the cadCAD wiki, enables participation from people, even if they don't want to get into coding necessarily.
Yeah, and here I would add, I mean, I'm a little bit critical about people who say, oh, I want to do token engineering and it's super cool, but actually I don't want to code, because this feels like, oh, I like painting, but I don't want to paint. So yeah.
Fair point.
Haven't heard that one before. Good. Nice. Well, we are at the top of the hour. I'm sure there's a lot more to discuss on this, and it sounds like it will continue being discussed. Are you, Quiet Catalyst, are you and Zane hashing this out on the side, or is this like in the study group sessions each week you're gonna try and pick a little closer to version 2? What would you say, where are you guys working on this?
Yeah, so it's both. We do some things out of cycle on the study group, mostly around doing things like creating those documents that I shared. And then this was the first study group since we started creating those where we could talk about it and get feedback. So I expect that in the study group for next week, we're going to continue on that trajectory. And depending on where that leads, try and navigate towards, all right, when are we ready to put the stake in the ground and actually kick off the next iteration.
Cool. Awesome. Well, I'll leave 1 second for any final questions before I wrap up. Does anyone have a final comment or question for Quiet Catalyst?
Just excited to see the next version of the study group. And let me know if we can support with anything.
Yeah, the thing that comes to mind is around speakers or experts who might come in at the end of the sprints and provide their perspective.
Yeah. I mean, this, of course, is probably also a call for the general cadCAD org community. Jeff?
Yeah. Yeah, and I know Block.Science too is closely related here, and I think that they'll probably have or be at least the first spot to stop for that resource. But obviously, the more the community grows, the more experts there are across it. So cool. And Patty, did you want to jump in?
Oh, I have some logistical questions, but I think I can drop them later.
Cool.
But I think the most important is just, when do you plan to start this?
The next study group? Yeah, I think we haven't set a date yet. We're working on refining the concept. I would expect it'll start sometime this month, but we haven't sort of dialed in exactly when.
Yeah. I guess in the meantime, the ongoing time slot is used to keep hacking away at the outline. So if you want to join,
Exactly. Yeah, if people want to join in and help shape it, that would be great.
Okay, so we have an open channel on the T Discord, and should we just leave it there and we also on the public calendar? And I wonder if Okay to leave them open or better to interrupt for the moment?
We want to keep those open because we are still meeting.
Okay, good. Thank you.
Awesome. All right. We're a few minutes past, so we can wrap up, but thanks again, cadCAD, for the awesome presentation. Lots of bonding curves and metrics and exciting stuff for cadCAD Study Group version 2. Sweet. Well, thanks for coming, everyone, and we'll see you next month / in between.
For the presentation, looking forward to hearing more as it develops.
Cool.
Yeah, thanks a lot for the presentation.
Bye. Thank you.
Bye, thank you.
Bye.